Alright, 9.2, squares and circles. I know that sounds kind of weird, but yeah, it's kind of how does the circle relate to powers of 2. So a little bit of background information. Again, hopefully most of this is review. There'll be a few new concepts here though, and especially one kind of comes in right at the end. First of all, distance around a circle. Hopefully you know this formula. This is nothing new. There's 2 ways to express it. I prefer the second one, but both are very useful in their particular problem that is given to you. Again, the distance around the circle. This is probably slightly new to you. If you only want a portion of that circle, we call it an arc. And I'm going to say that we should probably write that out as C, circumference, and then put a little L. You could write out the word arc, but you'll notice the next topic is area, and arc and area might look a little bit similar, so that's why I'm going to go, it's probably good to think of it in terms of the circumference as well. Well, if you only want a part of the circle, then it's just some sort of percentage times the circle, right? So the part. So the way that I tend to write this out is a percentage, yes, times 2 pi r. In fact, that percentage can be written as something over 360. So there you go. And that is called, by the way, the arc length. More on that in just a moment. But area. Area is the other one that uses pi 2, but this time it takes and puts the 2 as a power of r, not as a coefficient. And there is only one way to write that out, though writing it out as pi times radius is a helpful thing as well. Now, sometimes you will want a portion of the area. We call that a sector. And you can certainly, I tend to put a little piece of pi after the A to show that I'm doing the area, sector area. And again, we want a percentage of the area, pi r squared. And that percentage probably is best written as something over 360. Ever wondered why 360? Well, that's going to change shortly here. Not shortly, but in a year where we kind of ditch the 360 and we adopt a different way to measure circles. Now, as we look at arcs in a circle, there are 2 ways we can talk about these arcs. We can talk about the measure and the length. Really important thing to distinguish between those. Those seem like they might be similar. The measure is so many degrees. Yes, always measured in degrees. So if I think, how far is it from A to B, we measure that in as some portion of the degrees. Now, when asked for the length, yes, that's measured in units of linear length. So that would be like inches or meters, right? Some type of one-dimensional unit, not degrees. So here's an example. Find the length from A to B. First of all, again, this is based on 2 pi r. In this case, you could say 90 over 360, but it's probably best to just think about it as a quarter. We can see the radius from the problem. So I take the radius, which is 6. And again, this is the circumference, the length. Again, you could call it the arc. That's fine too. And 12 divided by 4 is 3, so 3 pi. And again, since this is the length, and this would be some sort of units, they don't give us the units there. All right? Now, what is the measure? And this is how we write out the measure of AB. We put a little m in front of the AB. And the measure of AB is 90 degrees. So there's our 2 answers. All right, and let's now do a sector problem. So the area of the sector, correct? Again, this is a quarter. And this would be then pi times 6 squared. Six squared is 36, and 36 over 4, I think, is 9. So this would be 9 pi. Leave pi in your answer, please. Don't kind of approximate it. Let whoever needs to use the number approximate it. We'll always report it as an exact answer. And there's one last formula we have to come to, but just, again, reminder of some terms. What is a chord in a circle? Okay, chord is the distance between any 2 points inside the circle. A diameter is a special chord in that it goes through the center. Inscribed angle is an angle that is whose vertex is on the triangle. And then an intercepted arc, when you have an inscribed angle, or any angle for that matter, inside of a triangle, yes, we have an intercepted arc. And so the intercepted arc in this case would be this little piece right there. Maybe I better use red here. Okay. All right, one last example here. Please pay attention because that last intercepted arc, there's a rule. Let's put the rule here before we do a problem. And the rule is that this angle here, call it x degrees, is related to this intercepted arc AB. And here is the relationship. And they don't equal each other. The angle is 1/2 the arc length. Okay? So an inscribed angle, the measure of that angle is 1/2 the arc length. Please make sure you write that down. That's a rule we'll use a lot more later on in Chapter 12, if we get to Chapter 12. But just a little introduction here. They throw in a couple of problems. Harry Health looks at a problem, and so here we have a problem, and we see the 80, and so what is the measure of angle E? Well, we have to take 1/2 of that, right? So that's 40. So the measure of angle E is 40 degrees. All right, pretty simple little problem, and most of the homework problems are probably about that difficult too. Okay.